Welcome back, everybody. In this video tutorial, I'm going to talk about prime factorization and what a factored tree is. Now, factors are the numbers that when you multiply together, you'll get a number. And a prime number always has two factors, the number itself and 1. For instance, 2 has two factors, which is 1 and 2. So we can say that 2 is a prime factor. Similarly, 5, 7, and 11 are all prime factors. They always end up with 1 times the number we started with. Fairly easy. Now, to perform a prime factorization, we can use a method called factor tree. A factor tree is basically taking a number and breaking it down into a multiplication problem that consists of only prime numbers. Now, without further ado, let's do an example. So let's say we have 12. 12 can be broken down into 6 and 2. Now, since 2 can't be further broken down into, we can go ahead and circle it, and we can say that 2 is a prime number. 6, however, can be broken down into 3 and 2. Circling both numbers indicates that 3 and 2 are both prime numbers. There's another way you can do this. Let's say, instead of starting with 2 and 6, we have 3 and 4. Since 3 is a prime number, we can go ahead and circle it. 4, however, is not, since we can break it down further into 2 and 2. And then circling both, indicating that 2 and 2 are both prime numbers. Let's do another example. Let's say we have 100. 100 can be broken down into 10 and 10. 10 can be broken down into 2 and 5. 2 and 5 are both prime numbers, so we can go ahead and circle them. Similarly, 2 and 5 are also prime numbers, and we can circle them. Another way we can break 100 down is by having 25 times 4. Now, both numbers are not prime numbers, since both of them can be broken down further. Starting with 4, Starting with 4 can be broken down into 2 and 2. And 2 is a prime number. 25 can be broken down into 5 and 5. And 5 is also a prime number. Now look at both factor trees. Notice how we ended up in each factor tree with the same numbers. So a shorthand to write this is by using exponents. So over here we have 5 times 5 times 2 times 2. And a shorthand way of writing this, like I said, would be using exponents. So we can just go ahead and write 5 squared times 2 squared. Since there are 2 2's here and there are 2 5's here. And the same thing applies here. Let's look at one last example. Say we have 144. 144 can be broken down into 12 and 12. Now 12 can be broken down into 3 and 4. 3 is a prime number, so we can go ahead and circle it. 4 can be broken down into 2 and 2. And they're also prime numbers. Now over here, you can do the same exact thing, but let's say you do 6 and 2. Since 6 times 2 will give you 12, and similarly, 3 times 4 will also give you 12. You're going to end up with the same prime numbers that you ended up with here. So since 2 is a prime number, we can go ahead and circle that. We have 6 that can be broken down into 3 and 2. 3 and 2 are both prime numbers, so we can go ahead and circle them. Notice how we ended up with the same exact prime numbers. We have 2 2's here and a 3, and we have 2 2's here and a 3 as well. So the shorthand for writing this is as follows. Since we have 1, 2, 3, 4 2's, we can say, I'll write it here. Use another marker. Since we have 1, 2, 3, 4 2's, we can write 2 to the power of 4 times, we have 1, 2 3's, 3 squared. This is a shorthand way of writing 144, or the prime factorization of 144. Thanks for watching, everybody. Please go ahead, like this video and subscribe. If you have any questions or concerns, please don't hesitate to leave a comment in the comment section below, and we'll see you in the next video.